Okay. Can. So let's just start with this one. Go through some of the mistakes you made with the differentiation. Okay. Yeah, let's go. So here, notation must have an extra pair of brackets because cos x bracket x plus 1 can be misinterpreted as this guy, cosine of the entire thing, right? So you have to be careful. Put a bracket there to avoid confusion. Yeah. Okay, what else? Very good. This one also very good. Yeah, it's correct. You're on question 9, A and B. Yes, this one, question 14, your working was fine. You just need to leave your answer in exact terms. Okay. You got the correct X, Y, and Z values. I sent you the message yesterday already. Just have to leave in exact terms. Okay, question 17, also mostly correct, except for the differentiation part. Over here, when you want to differentiate the second expression, there's a 128 times 1 minus cosine pi minus 2 theta. Then power, holding to the power of half. This part, what do you do? Right, you multiply the 128 inside, right? Inside the square bracket. Then there's a minus sign here, but it changed to a plus. Right? So it's wrong. Should be a minus. Other than that, it's fine. It's fine. It's just that because of the minus, then when you differentiate minus 128 times cosine 2 theta, you have to be a bit more careful. You'll end up with this 128. Yes. But actually, it should be a negative 128. Over here. Should also be a negative. Does it make sense?
Yeah.
Okay. Good. Yeah, then from there, yeah, the sign is just off. It should be a plus and a minus instead. Okay, then what you do next is you have to do that star, right? Differentiate equal to 0, solve for x, table to determine nature of stationary point. First, that's the first derivative test. Alternatively, you can also do second derivative test. Second derivative, more than 0, minimum point. Less than 0, maximum point. This one equal to 0 solve. I'll leave you to try on your own.
Okay.
Okay. And yeah. Also not so easy because it's a trigonal equation.
Actually, can you show me how to solve for if this equals 0?
Equals 0. Okay, can. Sure. Let's go. So show. Yeah, it's a bit difficult. I better show it. You can go and try again after this without referencing the working. So equal to 0, right? For SP. I'll just write it down. Set dA by d theta equals to 0. This means that you need to solve the equation. The moment I see a fraction, I will want to multiply throughout by this denominator. So what will I end up with? 64 cosine 2 theta times, wow, this is getting a little bit.
2 minus 2 cosine 2 theta plus 64 sine 2 theta equals 0.
When you have a square root, what do you need to do?
Square.
Square the entire expression, but maybe it would be smarter if you bring this guy to the other side first. Okay, so what do I mean? I mean 64 cosine 2 theta times square root whatever. Bring the other guy over, so negative 64 sine 2 theta. Then when you square the entire expression on the left, entire expression on the right. Actually, before that, I noticed something else. I can cancel out the 64 first.
Yeah.
Then bracket square. Yeah. If not, the numbers get a bit too big. So this guy is essentially A times B bracket square. A times B bracket square. This will be A square B square. So that will be cosine square 2 theta times square or square root, they cancel off, but don't forget the bracket. 2 minus 2 cosine 2 theta. Right? Good. Next one, negative sine 2 theta bracket square. So it's
Sine square
positive.
2 theta.
Exactly. Good. Oh, this will be a cubic. Not so good. We just add a page. Let's see how to solve this. Can multiply it now. So we end up with 2 cosine square 2 theta minus away 2 cosine cube 2 theta equals to sine square 2 theta. Luckily, everything is 2 theta, so don't need to use double angle identities or anything. Just keep it as 2 theta, I guess, for now. But there's a problem here. Cosine square, cosine cube, sine square. Who's the odd one out?
Sine square.
Sine, sine is the odd one out. So maybe we can make use of an identity that can help us to make it look more like cosines. Involving sine square. How about 1 minus cos square?
Yeah.
Of course, sorry, the theta should be 2 theta. Change the angle accordingly. Good, so you can substitute in. So as a result, we get the right-hand side being 1 minus cos square 2 theta. Okay. Let's just bring everything over to one side. So minus cos square bring over become plus, plus 1 bring over become minus. So we end up with 3 cos square. Right, because 2 plus 1 is 3. It's minus 1 bring over. Minus 2 cos cube. 1 bring over is minus 1, equals 0. I'll multiply throughout by negative 1 first, and I bring the 2 cosine cube to the left. Just to make it look neater. Not sure if I can solve this actually. We'll see, we'll see. This is an equation in terms of what?
In terms of cosine square. I mean, wait, what do you mean by?
Can you see a clever substitution we can make?
Yeah, cosine 2 theta equals to x.
Yes. Then this becomes 2x cubed minus 3x squared plus 1 equals 0. Cubic equation, how to solve? Remember your factor theorem, remainder theorem?
Factor theorem, remainder theorem. Factor theorem, if sub in equals 0, then it's a factor.
The x minus that root will be the factor, yes.
Yeah.
But we have access to a calculator, so just go to the calculator function, press mode 3 or whichever calculator version it is. But there will be a cubic
minus 1 and then 2x minus 1.
Yeah, so here there is actually an invisible linear term plus 0x. So there's the a equals to 2. There's the b equals minus 3. There's the c, 0. There's the d, 1. Key in the calculator, 2 minus 3, 0, 1. Oh, what do we have? We have
x minus 1 and then 2x
plus 1. Plus 1. Okay, I get x equal negative half or x equals to 1. If you bring it over, you get 2x equal minus 1. Bring it over again, you get 2x plus 1 equals 0. The other guy is x minus 1 equals 0. Okay, so end up with this. But there's a problem. How come only got 2 factors? Power 3. Power 3, we have 3 solutions, 3 factors. How come only 2?
Why? Yeah, why? I don't know. Why?
The reason is because the calculator is, if you're using a scientific calculator, most of them are unable to tell you which are the what we call repeated roots. You see, 2x plus 1 times x minus 1. Just look at x times x. This gives you 2x squared. That's not 2x cubed. Right? So what's missing is you're either going to have a power 2 over here times x minus 1 or power 2 over there. x minus 1. So which is which? I'm also not sure. You have to check them one by one. So let's consider case by case. Let's say if it's this, what will we get? 2x squared become 4x squared plus 2 times 2 times 1 is 4x plus 1 squared is 1 times x minus 1. This one, by the time you expand until here, you can see 4x squared times x gives you 4x cubed, right? But we have 2x cubed. So confirm wrong already. It will not be 2x cubed minus 3x squared plus 0x plus 1. You don't need to write the 0x. I'm just writing for emphasis. Okay, so that's wrong. Then it must be the other case. The square must be here. We can also check that. It will be the same as the 2x cubed minus 3x squared plus 0x plus 1. Expand 2x plus 1. Expand x squared minus 2x plus 1. Get the cubic term. How to get cubic term? Power 2 times power 1. 2x cubed. I'll highlight in yellow. How do you get a power 2 term? Power 1 times power 1. What else?
Plus minus 2x.
Minus 2x. Hold on a second. Why got minus 2x?
Wait.
You want the power 2 term. So let's say we take 2x times a negative 2x.
I mean plus
get 1?
1x squared.
Plus 1 times the x squared, right? Okay. This is from binomial expansion. Must remember how to pick out the exact power terms. So over here, it will be, what is it? 2x times negative 2x, that's negative 4x squared. And then a positive 1 times the x squared, so it's a plus 1 x squared. Okay, then how do you get the linear term, power, the power 1 term? So I use orange. 2x can multiply by
1.
positive 1.
1 times minus 2x, so actually nothing. So plus 0x.
Okay.
And the 1 is just 1 times 1.
Yeah. That's why there's no x. Okay, let's just write it down. Write the working. 2 times 1 plus positive 1 times negative 2. So minus 2 times 1 x. And then plus 1 times 1. Okay, and of course, yes, it is the same as 2x cubed minus 3x squared plus 0x plus 1. Okay, if you didn't have a calculator, what you would need to do is to take this expression, call this f of x, equals, sub in x equal to 1, trial and error until you get it. Then f of 1, you sub in. So you get 2 times 1 cubed minus 3 times 1 square plus 1. You realize this is equal to 0. This tells you that x minus 1 is a factor. One of the factors. You won't know whether it's power 2 or not. So you have to write down x minus 1, then you can do long division, right? Long division to go and figure out the other factor. You need me to recap with you long division?
No, it's okay.
Okay, good. Then we move on. So anyways, solving, we get what? X equals negative half or x equals to 1 twice. Are we done? Solve for capital X. Was that the question?
No, must solve for.
It was a dA by d
theta.
So we must replace the x with cosine 2 theta. Right, remember I say I let x equals to cosine 2 theta. So we must replace it back with the original cosine 2 theta. Okay, good. Okay, let's solve the first guy.
Cosine inverse negative half.
Find your little fish first, alpha. Cosine inverse negative half, negative, are you sure?
120.
Oh no.
Wait, I mean.
What's the first step? Do you consider, what do you do to the negative sign?
Ignore.
Ignore it, yes, then cosine inverse only the positive
60.
half, which is 60 degrees. Sorry, no. We are dealing with differentiation. Please use radians. 60 degrees is pi over 3. This is alpha. What else do we need? A, S,
DC.
negative.
We need
Which one? A, S, T, or C?
Wait,
Which quadrant? This is 1, 2, 3, 4.
1.
Sorry. Can you excuse me for a bit?
Yeah.
Like this.
Yeah.
Hi, sorry. Okay, back. What was I saying? Right. We found the alpha, the reference angle, basic angle, pi over 3 in radians because we're doing differentiation now. So which quadrant for negative value?
S and T.
S and T, okay, good. So just circle these two. So that means that your final answer for 2 theta, not theta, it's 2 theta. Follow whatever is in between the brackets. Equals to?
Pi minus pi over 3.
Okay, good.
Or pi plus pi over 3.
Good. Okay. Simplify, we get 1 minus 1/3, 2/3 pi. Next one is 1 plus 1/3, 4/3 pi, or pi over 3. That's 2 theta, okay? That's 2 theta.
Then
Are we done?
no.
Oh, solve for theta.
Yeah.
Divide by 2, pi over 3. Divide by 2. 4 over 2. 2 pi over 3.
Yeah.
Yeah, okay. Your fractions. Go practice. Next one.
Then plus 180. I mean plus pi. Then
what should you do first? Whenever you see a positive 1, 0, or negative 1 on the right hand side?
Positive.
When the right hand side is forgot already. Straight away you need to draw the cosine graph.
Okay. I cannot draw on this.
But it's 2 theta. Oh. Okay. MCQ for you.
Okay. That's sine. That's cosine. Oh, shoot. Which one is it? It's the
option
last
1, option 2, option 3.
It's option 3.
The last one. Option 3. 2 theta requires 2 copies from 0 to 360. Need to remember that. If it's 3 theta, squeeze a bit. This will become 2 pi. Okay, wait. And draw it more precisely. Let's say, for example, if it was this guy, you see 3. Not enough space. 3 down, up patterns, and it ends at 2 pi. This is cosine of 3 theta. If this is theta axis, this is y axis. Y equals cosine 3 theta. Okay? Makes sense, huh? The coefficient tells you how many repetitions there are from 0 to 2 pi. 360 degrees. Okay, I'll put that aside. Yes, the correct answer is option 3. Option 1 is a sine curve. Option 2 is a cosine 1 theta curve. 1 theta, just theta lah. This one is sine theta. Okay? Oh, not x, theta. And y-axis, origin. Okay, very good. So correct answer is option 3. So equals to 1. That means there's a y1 over here. There's another y2 over there. We've already drawn y1, right? y1 is the curve. Now we have y2. So we must draw y2 over here. Horizontal line, y equal to 1. Can? Then where's the intersections? Here, here, here. The corresponding x value, what is it?
0 pi and then 2 pi.
Yeah. That gives you the answer to theta straight away. Alternatively, you could have also drawn cosine theta. But sorry, think of this as cosine, I don't know, think of another letter, let's say W. Okay. Then cosine 2 theta equal to 1. You get these two as your answers. Sorry, these two as your answer. So 0 and 2 pi, right? That means 2 theta will be 0 or 2 pi. Right? Then over here, if you divide by 2, you end up with 0 and pi. Oh, it doesn't work. What's wrong? What's missing?
The 4 pi divided by...
You needed to draw an extra copy of this to know that there's another 4 pi intersection. Then you divide by 2 to get your 2 pi answer. Right, so what you had to do was plus 2 pi to this one, which will give you 4 pi. Then you divide by 2 to solve for theta. Divide by 2. Maybe I use a different color for the divide by 2. Divide by 2. 2 color, divide by 2, and then you get your 2 pi. So up to you which one you want to draw. The original cosine curve or the one with 2 copies. Then just find the point of intersections and their corresponding x coordinate. All right.
Okay.
So we get these 5 values. Let me see the question again. I forgot the question already. Find the value of theta which gives x a maximum value. Okay, so it's trapped inside an isosceles triangle, so it actually cannot be so too big, the angle. All right, it's actually probably isosceles triangle is a base angle, so it's actually less than 90 degrees. Right? Base angles cannot be both 90. Base angles must be equal, cannot both be 90. That would be too big. So it has to be less than 90, more than 0. So actually we can reject a lot of the answers. Cannot be 0. Maybe we find a different color. This one, reject. This one, reject. This one also reject. This one, 2 pi over 3 is how much? 2 pi over 3. Let me think.
120.
120. So this one also reject. So end up we only have one correct answer, which is the acute angle. Theta equal pi over 3. Reject because theta must be between 0 to 90 degrees. Sorry, don't use degrees, use radians. 0 radians, pi over 2 radians. Because base angle of isosceles triangle. Okay, that's good. So what? So we now need to answer the question. You don't just solve for theta. You must answer the question, which gives us a maximum value. How do you know it's a maximum value? You don't know for sure. So you need to start the theta back in to the formula for S, get the value for the S. Okay, then after that, you need to determine the nature of that point. Maximum, minimum, or stationary point of inflection. So let's just finish up the question. Last step. What's the expression for s again? Here, 32 sine pi minus 2 theta plus 4 times something, something, something. So therefore, as equals pi minus 2 pi over 3, times 2, plus 4 times the square root of 128 bracket 1 minus cosine of pi minus 2 pi over 3. Let's say we try to get the exact answer. We can try to get the exact answer. Then in that case, what's pi minus 2/3 pi? 1 apple minus 2/3 of an apple, 1/3 of an apple level. But in this case, not apple, it's a pi. So pi over 3. What's sine pi over 3? Sine 60 degrees, right? Which is exact value?
Half.
Huh? Oh, no.
Wait, I mean, square root 3 over 2.
Very good. Yes. Next one. Plus 4 times square root of this guy. Let's see. This one 1 minus 1/3. Sorry, 1 minus 2/3 is 1/3. So it's cosine pi over 3. What's cosine pi over 3?
Cosine pi over 3 would be 60. I mean, cosine pi over 3, cosine 60, which would be half.
Yes, correct. How did you arrive at half?
I use calculator.
Okay, very good. You square first, then you square root on your own, right?
No, the pi, I mean the cosine 60 didn't need, but the sine
correct.
pi over 3 needed to, for me, 0.1, then I just press square. Then,
yeah. Good. Square, for those that have square root, then you need to do the trick. Square on a calculator to get the exact value, 3/4. Then from there, you work backwards. Square root this guy becomes square root 3 over square root 4. Square root 4 is just 2, so square root 3 over 2. Then you don't need to memorize so much. Like you just need to memorize one procedure. Square on a calculator, square root on your own. I'm sure you know your exponent rules, so square root 3 over 4 becomes square root 3 over 2. You can handle. Anyways, yeah, so it's a half. So 128 times 1 minus half. 1 minus half is half. 128 times half is 64. So square root 64, which is, I'm just going to take a shortcut and rewrite this as 8. Is it too fast?
no.
Oh, okay, good. So 3 over 2 root 3 plus 4 times 8. 4 times 8 is 32. So 32 plus 3 over 2 root 3. Okay, that's the maximum area, but we don't know for sure if it is our maximum or not. So we need to use, I would prefer second derivative test. Let's try second derivative test. Hopefully it doesn't give us a 0 after we sub in. If not, that one really no conclusion. So let's try second derivative test since you're practicing how to differentiate trigo expressions. Let me find your first derivative first. Over here. So second derivative, d2a by d theta squared. Right, differentiate term by term. How many terms do you see?
1, 2.
2 terms. So first term, differentiate. Factor, what do you do?
Bring out the 64.
Leave it alone, 64, leave alone, times?
Times d over d theta cosine 2 theta, which would just be negative sine 2 theta.
Don't forget the 64. Negative sine 2 theta. What else?
Times 2.
Must remember chain rule. So you still need to do times 2. Close the bracket. Okay, that's the first term done. Plus. Now the second term.
Can bring out the 64 again.
Yes. Okay, so 64 multiplied by derivative of the remaining half. remaining part.
Can
let me just shrink.
use the rule.
Quotient. It's a fraction. Then
Low D high minus high D low. Draw the line square below.
yes. So low is this guy.
And D sine 2
Times-
theta will just be cosine 2 theta times 2.
Yeah, if you're faster, go ahead. Okay, can I just skip that step? I don't write this, I just immediately replace.
Yes, can.
Can cosine 2 theta, and then don't forget chain rule times 2. Low D high done. Less
Then
means minus.
plus,
High D low.
sine 2 theta, then times half,
Half. Good.
then times 2, and bracket open 2 minus 2 cosine 2 theta, bracket close, minus half, then times differentiate the inside, which would just be.
Give me a second. I'm running out of space. Let me just bring it down here. Carry on.
Which would differentiate the inside, which would just be negative 2 times sine 2 times minus sine times minus
sine.
sine
Good.
2 theta times 2 cos chain.
Correct. Like this. Make sense? The 2 here, okay. The 2 here, you differentiate, you get a 0. Let me just be super precise and put a 0 there. Okay, you don't, of course, 0, you don't need to write it. Differentiate this first term, you get a 0. Negative 2, you factor out. Cosine 2 theta, okay, too many highlights. Let me just do this. Minus 2, you factor out. And then cosine 2 theta here, you differentiate. And you get minus sine 2 theta times 2. And this 2 is because of chain rule. Can you see what's going on? Okay, must have all the brackets. Just put as many brackets as you want. Don't need to bother with the round, square, and curly brace. Just round all the way is okay.
Oh yeah, I was doing the question, then I had to like redo because I don't know what's like after you put the I don't know what's the
Yeah, there's no notation after curly brace, is it? Just restart round, square, curly brace, round, square, curly brace. I mean,
really?
To be honest, yes. But to be honest, nobody follows that much. We all just use round brackets in the future in uni math. Yeah. Yeah. Okay, then after that, all divided by low D high less high D low. Draw the line and
square below.
Square below. Square root cancel away. Left with just 2 minus 2 cosine 2 theta. Very good. Oh, I'm starting to regret doing this. Never mind, continue. Minus 2 times 64, so minus 128 sine 2 theta plus, okay, I see that there's a factor of 2. I can factor it out. Let me just take a shortcut and rewrite this as 1 minus 1 cos. I don't need to write the 1, so I just erase that 1. I rewrite it as 1 minus cosine. 64 and 2 cancel away. This becomes 32. That becomes a 1. Don't need to write the 1. 1 times anything is just this thing itself. So we are left with our 32 denominator on the numerator as a factor. Then the rest just copy and paste, but simplify a bit. So 2 cos 2 theta, I'll write it first. Then I write a square root 2 minus 2 cos 2 theta. Minus, let's see. Wow, this is complicated. Let me just simplify it at the side. Sine 2 theta times half times, this is 1 over square root 2 minus 2 cos 2 theta times what's inside the bracket? 0 minus 2 times minus sine 2 theta times 2. Minus times minus is positive. 2 times 2 is 4. So it's just 4 sine 2 theta. Right? This part is 4 sine. Okay, 4 and half cancel away. Then you're left with sine times sine, which is sine square 2 theta. all over square root 2 minus 2 cos 2 theta. Is it okay so far?
Mm-hmm.
Can Okay, good. Then copy and paste. Put it here. Close the bracket. Black color. All divided by 1 minus cosine 2 theta. Okay, I cancelled off one of the factor 2 just now.
Yep.
All right, that's good. Simplifying is not so important. What's more important is to answer the question. Second derivative test. You need to do what after finding second derivative? Sub.
More 0, less 0.
But before that, you need to substitute.
Substitute the theta.
Yeah.
Equals to pi over 3.
Yeah, this root here, pi over 3. Okay, so that's what we're gonna do. Let me add another page. Wow, really no space. Okay. Oh, here. Okay, good. So this, let me just write it here. So next step is d2a by d theta square. Substitute theta with whatever we found, pi over 3, right? Pi over 3, good. Then we're gonna determine whether it's positive or negative sign. So let's see. Sine of 2 theta is sine of 2 pi over 3, which will be pi over 3 is 60 degrees. So this will be 120 degrees. Sine of 120 degrees. Acute angle is 60. This is quadrant 2, so it's still positive. So positive sine 60, which is root 3 over 2. Multiply by negative 128. Let's see what that is. Negative 128. Actually, you know what? Since we only care about the sign, exact value also doesn't matter. Exact value doesn't matter. Okay, let's just go. Type the whole thing in a calculator. Pi over 3, shift store as A. Make sure you're in radian mode.
Oof.
Yeah. Yeah, there's a lot to type. So just be careful. Wow, another fraction. Okay.
Do you get? Oh, I got syntax error. I was like,
be careful of open bracket, close bracket, that kind of thing.
yeah.
Follow exactly. Right? You see open bracket, you put open. You see close, you put close. Yes.
I get negative.
Unless I type wrongly, there's a chance that could happen.
Oh, yeah. Okay. Yeah.
Correct,
Yeah.
Okay, so anyways, you get this number less than 0. Conclusion is S is max or min.
It is a maximum point.
Yeah, max. Very good. Okay, that's it. It's maximum when theta equal pi over 3. Okay, very good. Next. Move on. Help you solve one question. I'll go and try again on your own. Now, question 20. This is quite interesting. This is teaching you how new identities are discovered. Okay, so like for example, secant x, you differentiate, you get secant x tangent x. How do you get that? You just have to realize secant x is 1 over cosine x. You can rewrite it as power negative 1, exactly what you did. Use chain rule and you get the answer secant x tangent x and a few trigo identities. Then you get the final answer. The next part, part 2 is to speed things up, you're supposed to use part one. Okay. So whenever we tell you differentiate secant x, you get secant x tangent x. By the way, if part one cannot do, part two can still use the answer from part one. What happens if I change that secant x now into secant of, let's say, 3x? Then what would this be equal to? Do you need to do the whole procedure again?
No,
Don't need. What you need to see is that there's a
with chain rule.
composite function, so you use chain rule. So that means that you just copy whatever was the right-hand side answer, differentiate, you get secant times tangent. But whatever is inside, you copy and paste. But chain rule tells you this whole thing, you need to multiply by derivative of the inside, which is 3x. D outside times D inside. Okay, chain rule. Then just copy and paste the first part, secant 3x, tangent 3x times 3. Okay. Can? Good. Okay, can. What happens if I upgrade this into 3x squared? Still the same thing. Whatever is inside, you remain. But then now this changes into 3x squared. Can you see the pattern?
Times 3x squared. Okay.
Yeah, basically whatever is inside, put it inside there. That's the D outside, while keeping the inner argument the same. Then D inside is asking you, look at this guy, differentiate it. So 3x squared now becomes power rule. Factor out the 3, differentiate x squared, you get 2x. 3 times 2x, 6x. So this upgrades into 6x. Clear? Yeah, so every time you're given a function, you see x on its own, you must think more flexibly. X can always be replaced with other functions. You can even have a e power x squared inside. You can also proceed with the differentiation. Just copy and paste e power x squared, then differentiate e power x squared. Okay. Yeah, I'll leave you to think about it. Can be anything. Can be anything. So that's the purpose of this question. When they change it into a 2x, just replace it with 2x, and differentiate 2x using chain rule. You don't need to redo. You are redoing it, the entire thing. Oh no, the page got. I add a new page. Let me see. The arrow disappeared. Okay, you get the idea, right? You can jump straight from here to there. Okay, good. Then you submit x equal to 3, you get the answer. The rate of change question, quite simple. Just take note of your notation. When you never put vertical line, it cannot be equal to a number. It's still an expression in terms of x. To be technically correct, you should put vertical line x equal to 3. Okay? Yeah, next. Okay. So question 23. What happened? Part 2 is wrong. Okay. Let's see the question. You start off with y equals what? X plus cosine x. Do you know how it looks? No. I never teach you how to draw a graph with x. I only teach you how to draw cosine x, cosine 2x, cosine 3x. And then if you plus 1, minus 1, or if or in general, a times cosine of bx plus c, where a, b, and c are constants. I did not mention cx. No such thing. Cx, too difficult already. If there's an extra x there, you need to use differentiation and a few more tricks to figure out how to draw the curve. Okay, this is what we call a linear transformation. Up to this step only. Maybe I use a different color. Linear transformation. Plus scaling. Scaling the x via b. All right, so now this case, part 1, find x coordinates of all stationary points. You did it. Yes, good. There it is. Part 2, determine nature of each stationary point. When you see nature, please remember it's the TA step in the DESTA. That's the TAR step. Table, first derivative test. Okay, or second derivative test. So you didn't do that and you concluded maximum straight away. Can you tell me why you said maximum?
I was looking at the graph that I drew.
You're looking at a graph that you draw to help you to solve the equation. But that is the derivative, right? And actually, no, that's not even the derivative. It's just a sin x curve. That's not x plus cos x, so you cannot tell the nature of the stationary point. Okay, so you need to do a first derivative test. I think I did not do it for you. I didn't. Let me see. Yeah, I didn't do it for you. I'll leave you to try on your own. Go ahead and do first derivative test on your own on these two fellows. Figure out maximum or minimum. Then yeah, part 3, explain why has why has no maximum or minimum points. The idea is that when you look at these two guys, you try and determine their nature. There are only 3 possible conclusions, right? In general, before you even look at the question.
Maximum or inflection.
Very good. Minimum, maximum, or inflection. So here they say not maximum, not minimum. So from there, you can guess already. What do you think is the answer to part 2? Not maximum, not minimum.
Inflection.
Inflection point. And I think I already took a screenshot of the graph for you. Here is how the graph looks. Is it not? Did I draw the wrong curve? Let me just double check. Yeah, over here, the gradient is not horizontal. The gradient is, this is not a minimum point. It's actually a bit slanted. Actually, I can show you the original curve before I restricted the domain. By the way, this part here, the curly brace is restricting the domain. I make sure that the graph only plots points where the x is in between these two values. -3 pi over 2 to pi over 2. Actually, maybe I shouldn't have done that. I should go for -2 pi to pi. Right, I just realized that. Let me see if I can show you the decimals right now. Yeah, I can. Okay, good. Oh, it's blocking. Let me move this away. X. Can you still see my screen now? The decimal screen. Okay, this is how the curve looks. Okay, it's a snake. Zigzag. If I plot the interval, it will be curly brace, pi, -2 pi, pi for pi, less than or equal x, less than or equals, what was the value? Is it pi? Yeah. Then you want x equals -3 pi over 2. That's your x coordinate of the first stationary point. And x equals, I can't remember already. What was it? Let me check. Pi over 2, right? Okay, so this is the curve they want you to draw, the red color one. Or not draw, just without drawing, you can answer the questions. There's a x equal -3 pi over 2, x equal pi over 2 vertical lines. They intersect here and here. So those are your 2 stationary points. Let's zoom in on the left stationary point, this guy. So clearly you can tell it's a point of inflection, right? Not maximum, not minimum. Likewise over for the second stationary point here, also inflection point. Okay. Yeah, and the question only interested in a graph from -2 pi to pi, so the rest of the curve, you don't need to look at it. You just have to care about this red color short little curve. Those part of the curve beyond -2 pi and beyond positive pi, don't care. Not relevant to the question. Okay, that's it. That's what they are asking you. You get inflection point, not maximum, not minimum point. Any questions?
No.
Yeah, then for part 4, sketching the curve, how to sketch a curve? Let me just give you the pointers. First one is find the intercepts. That's not the full spelling. I'm writing a short form. X-intercepts, Y-intercept. For x-intercept, sub y equal to 0. For y-intercept, sub x equal to 0. Okay. Next one, asymptotes. Whenever you have a fraction going on, like for example, y equals to x plus 1 over x, this guy, you're dividing by x, correct? But you can never divide by a very special number. What number is that? It will cause math error. Never divide by
0.
So that means that you cannot divide by 0, so x also cannot be equal to 0. If you sub in x equal to 0, what happens? Divide by 0 here, math error. So we must prevent that. And that tells you that there will be what we call a asymptote here. Asymptote. The graph will have a vertical line. Let me just quickly draw a sketch of the curve. If you do a bit of long division, this will be 1 plus 1 over x, which means that the graph will look something like 1 over x, but increased by 1. Okay, it looks something like this. And there is a vertical asymptote over here. This is x equal to 0, which also happens to be the y-axis. Of course, if I modify this into x minus 1, then it will be x minus 1 not equal to 0. Okay, x minus 1 not equal to 0, which means x not equal to 1 is the vertical asymptote. In that case, the graph will be quite different. Let me just do a quick sketch of that curve. X plus 1 over x minus 1. Wow, this is a bit challenging. Okay, not really. X minus 1, you can rewrite, x plus 1 can rewrite as minus 1 plus 2, right? So you can split this up as x minus 1 over x minus 1 plus 2 over x minus 1. X minus 1 cancels away, you're left with a 1 plus 2 over x minus 1. This means the curve will have a vertical asymptote at x equal to 1, and it will have a downward, a curve that looks something like the following. Curve down here, horizontal asymptote y equals to 1. Technically, I never teach you this formally because this is a H2 math topic. But I'll just let you know, graph sketching tricks. Look out for asymptotes. Okay? Oh, wait, this has to be a bit lower. When you sub in x equal to 0, you're gonna get 1 plus 2 over 0 minus 1, which is 1 plus negative 2. 1 minus 2 is negative 1. So I need to cut at negative 1. Yeah. Okay, but anyways, that's just a quick sketch. Point number 3, turning points, TP. Okay, not traffic police, not toilet paper, it's turning points. Also known as stationary points, aka SP. Not Singapore Poly, is stationary points. Stationary points. For turning points, you know there are 3 types, right? Max, mean, inflection. Okay, you know how to, starting from there, you know how to sketch the curve roughly, right? There is another point that is also not, not technically in the AMAX syllabus. It's called the curvature of the curve. Whether it's a happy face, we call this concave upwards. How to remember? CUP. Combined together gives you cup. How do you draw a cup? It looks something like this, teacup. Oh, then you can see a happy face here. Cup. Okay. Next one, set face, concave downwards. Opposite of upwards, downwards. There's another word called convex. You go and Google on your own. What is convex versus concave? I only know these 2 phrases. I don't want to confuse you with those other 2. You can determine, so anyways, happy face or sad face. You can determine the point at which a curve changes its curvature, meaning it changes from happy into sad face or sad face into happy face by doing what's called a sign test on the second derivative test. So sign test is like is similar to your first derivative test where you draw the table, but that's the sign test on a first derivative. that helps to determine the nature of SP, happy max, min, or inflection point. But if you do sign test on the second derivative test, second derivative, this is not related to second derivative test. It's a sign test on this guy. You draw a table again. You'll be able to determine the points at which they change their curvature. So for example, if you have a curve that bends like this, it's like the left half of a set face, right? Left half of set face. Then suddenly it changes. It changes into this curve, which is the right half of a happy face. Can you see? So it changes from a set face to happy face. This particular point, there is a corresponding x coordinate. You can find this by doing a sign test on d2y by dx squared. Okay. Yeah, extra. This one don't need to know. Don't need to know. This one, number 4, don't need to know. Asymptote. Maybe, yeah, you actually need to know a little bit from logarithms. The others you already know, 1, 2, and 3. From all this, you are able to tell how to draw the curve. Okay? One more actually. Sorry, I forgot. You also know this. Increasing or decreasing function. dy by dx is positive for increasing function. dy by dx is negative for decreasing function. Then from there, you can tell from x equal to 1, let's say, to x equal to 2, if it's increasing, your curve sketch better go up. You don't 1 to 2, you go down. If your dy by dx is more than 0. Make sense? Increasing, decreasing. Okay, can Yeah. Then I'll leave it to you to draw on your own. I mean, you can also use software to help you. Maybe you can try as an exercise. You don't look at the final answer yet. Then you go and use these techniques, 1, 2, 3, 4, 5, ignoring the number 4, and try and sketch this curve. Okay. Of course, maybe also a small point is sub in the what do you call it? The domain endpoints. Like here, they tell you that they only want x values in between -2 pi to positive pi. You can substitute x equal -2 pi, get the corresponding y coordinate, plot a point. Sub in x equal to pi, get the corresponding y coordinate, plot a point. Then from there, you join the dots together with a smooth curve. Okay, good. Let's move on. Stop me if you got questions. Question 25, let's go. Given a curve of y equal to sin x times 1 plus cos x, it's really just the same question. Sketch the curve. Indicate clearly coordinates of all the stationary points. Really, when they ask you to sketch a curve without using her software, you need to know everything about the calculus already. You need to differentiate, equal 0, solve for x, get your stationary point, maximum or minimum. You must also do first derivative test table or second derivative test if you want. If you don't do that, you won't know how to draw the curve. Yeah, so this question is quite evil in a sense. They are testing you on everything. Okay, so I tried to write out the answer for you. First thing, let's find the intercepts. Let's find the x-intercept. So sub y equal to 0. Okay, so we get sin x times 1 plus cos x equal to 0. First factor, second factor equals 0. Solving, you get x equals 0, pi 2 pi, or -1. Hopefully you remember that 0 or, sorry, I shouldn't be boxing that. I should be boxing this guy. 1 times cosine x or 1 times sin x, and then equals to a 0, -1, or +1 on the right-hand side, tells you that you must straight away draw the curve. After drawing the curve, find the corresponding solution by just reading the graph. This part okay or not? Can, good. X-intercepts are found. 0, 0, pi, 0, 2 pi, 0. Please note that these 3 points have no relation to cosine x and sin x. It's referring to this graph, okay? It belongs to this graph. Clear so far?
Yeah.
Good, next. Now we go on to y-intercept. Sub x equals 0. Sin 0 is what? 0. 0 times anything? 0. So straight away you get a 0. If you want, you can calculate a 2, but no point. 0 times anything is just 0. Okay? Good. Next one, turning point. Differentiate equals 0, solve for x. Substitute get the y, draw a table, first derivative test. I'm sure you know the procedure by now. So just go through it. What happens is sine x times 1 plus cos x. I realize it's a product, right? Product, then use product rule. So how do I do it? Let me just label this as 1 and other. This one is keep 1. This one is differentiate the other. This guy is plus. This one is keep the other, 1 plus cos x. This part is differentiate 1. Make sense? Keep 1, differentiate the other, plus keep the other, differentiate 1. Keep 1, differentiate the other, plus keep the other, differentiate 1. Just repeat until you can remember. All right. Okay, moving on. So simplify, you get negative sine square plus cos x plus cos square. Then you just bring the cos square over to the front. Why? I don't know. I just like it. Cos square x minus sine square x plus cos x. Both are fine. Then the next step is to equate to 0. So for SP, set dy by dx equal to 0. Good. We get this guy equal to 0. Okay. Then that's when you must go back to your trigo equations and trigo identities. Here's one possible way that I attempted. I realized cos square minus sine square is cosine 2x. So I substitute in. Then I end up with cosine 2x plus cos x equals 0. I stare at this and I'm like, oh no, not good. Why not good?
Because 2x.
2x and x in the same equation as the argument of a cosine. Okay, having cosine and cosine is good, but having 2x and x different is bad. You need them to be the same. So this is not good. We don't try this method. Instead, I realize, oh yeah, we have this identity, sine square plus cos square equal to 1. I see cos square, I see sine square, I see cos x. Who's the odd one out? Sine is the odd one out, right? Left with cos, right? So same as the previous question. Replace sine square with 1 minus cos square. Okay, so don't be careful of the minus sign there. So bring in the minus and you end up with a plus cos square minus 1. Okay, or minus 1 plus cos square. Then you just combine everything, you get this guy, 2 cos square x plus cos x minus 1 equals 0. Not enough. You still need to solve. You realize it's a hidden quadratic. Hidden quadratic. After you do a clever substitution. Clever substitution. What's a clever substitution? Capital X equals to cosine x. So this becomes 2x squared plus x minus 1. Quadratic can be factorized into this. Solving, you get half and negative 1. Then, do we stop at capital X?
No.
No, go back to little x. So go back to cosine. So cos x equal to positive half, cos x equal to negative 1. Do you need me to go through with you or can I just jump straight to the answer?
Can just jump straight.
Okay, I can. So here are the 3 answers. I'm sure you are bored by now. You go and read on your own how to figure out the answer to these 3. After you get those 3 x values, not done. This is just the x coordinate of the SP. We still need the y coordinate. So have to substitute back in to the original expression for y. You at the end of the day, you get 3 root 3 over 4, negative 3 root 3 over 4, and a 0. What does it mean? To put it neatly, it means I have these 3 points as my stationary points. What else is missing after finding stationary point? What kind? What kind of stationary point? Right? So what do you need to do next?
Table.
Table, yes. So that's exactly what I did next. Just copy it down for neatness. 3 stationary point, 3 tables. Painful or not, this question? I write out all the solution for you. Please go and read. Try again on your own. Yeah. So anyways, you get a maximum point, inflection point, and minimum point. Okay. And yeah, that's it. Okay, not enough. You still need to go and sub in the boundaries of the domain. In the question, they requested for 0 less than equal to x less than equal to 2 pi. So those are your 2 boundaries. Sub x equal to 0, get a y. Sub 2 pi, x equal to 2 pi, get a y. That's exactly what I did. I get 0, 0, 2 pi, 0. Okay. But actually, if you look carefully, 2 pi comma 0, we actually got the value, we actually already got that coordinate. In fact, 0 comma 0 as well from here. They happen to be the x-intercepts because y coordinate is 0. Okay, cool, interesting. So gathering all this information together, what we have is x-intercepts here, 3 of them. Y-intercept, 1 of them. Of course, they are the same, x-intercept and y-intercept, because it's the origin, right? Turning points, you got these 3. Nature is right there. Domain is right there. Don't go beyond negative, don't go to negative values of x. Don't go to values bigger than 2 pi. Keep within the domain. Stay within your territory, requested by the question. Okay, with all this information, you can now draw the curve. Ta-dum. Plot the points, right? All these points, and just connect the dots. This is maximum, that is minimum. And that's our inflection point. Don't need to label, but I'm just gonna label for emphasis, maximum, minimum, inflection. Inflation, inflection. All right, then actually, to be even more technical, there is actually a point where there's a change in curvature. It changes from a right half of a sad face to the left half of a happy face. Yellow change to blue. Here it's right half of a sad face and left half of a happy face. Blue to yellow. Concave downwards change to concave upwards. Concave downwards change to concave upwards. That's a technical way to say it. But I prefer happy and sad face. Change from sad face to happy face, change from sad face to happy face. There's a particular point there. I did not go and find I didn't bother to go and find the coordinates of that point. Because it's not in the syllabus. Don't need to know. Okay, even if you didn't show it, it's fine. The graph is acceptable. Okay. Any questions? No. Okay, move on. That was only part 1. This sketch the curve, so troublesome. Part 2, hence sketch the graph of this fella for 0 less than equal x less than equal 2 pi on the same axis. What are these things? Vertical line. Chopstick. Can eat or not? Oh, what is it?
It is the one that, yeah, absolute.
Absolute value, also known as modulus. Let me just write this down. Modulus function or absolute value function. Don't need a dash. Absolute value function. What does it do to the graph?
What does it do to the graph? It makes it not be negative.
So which parts of the curve are negative, above or below x-axis?
The parts below the x-axis.
So if it makes things positive, it means the negative must go up. In other words, the parts below x-axis must go up.
Yeah.
In fact, more particular, specifically, when I say go up, I mean reflected above. To convince, I think the easiest way to convince you is to just draw a few examples. So let's try. Let's say x plus cos x right there. Let's now try the modulus of it. Modulus x plus cosine x. Yeah, the modulus is. Give me a second. I need to put brackets. Open bracket x plus cosine x. Close the bracket. Then absolute. Is it not? This way. Okay. Absolute on the left side. Okay, what do you see? Okay, this one I remove the domain. This is the original curve. You get rid of the vertical lines. Dum, modulus, what happened?
It reflects about the x-axis.
But what about the part that's already above x-axis?
It just remains the same.
Very good. Exactly. That's it. So that's exactly what we're gonna do now. So just look at the sketch. We're gonna reflect this thing up above the x-axis. The one that's already there, you keep it the same. So I'll just use blue color. I hope you can see. Maybe I use a bit thicker font size. It stays exactly the same, but then now you have to reflect the other half on top. Take note that this particular point here, it was 5 pi over 3 comma negative 3 root 3 over 4, and negative 3 root 3 over 4. If you bring it on top, reflect it on top, what value does it become?
It becomes
Mirror, reflect.
um
This is like the center.
negative 5 pi over 3. Then
Ah,
positive.
negative 5 pi over 3. Negative 5 pi over 3 is on the left side of the y-axis.
No, I mean,
What stays the same?
X stays the same. Y changes.
Change in particular, how? Times?
Negative
1. Exactly. Good. So that means you just have to be careful of the reflection. Let me just model it. And also, by the way, positive, after you multiply negative 1, positive 3 root 3 over 4 is the same as this point over here, which was the maximum point. So make sure that when you reflect, it's the same height. So I'm just going to do that. Font size increase. So roughly something like this. Okay. M shape. Okay. Yeah, let me just convince you by drawing using decimals. Sin x 1 plus cos x, is it? Okay, let's go. Sin x 1 plus cos x. Sin x, bracket 1 plus cos x. To be less confusing, I'm going to put an extra pair of brackets. Like this. Okay. Then I'm going to do something known as a function notation to make my life easier. F open bracket x close bracket equal. Okay, so fx equals to that guy, the black color curve. Can? Just change the scale a bit to make it look nicer. Something like this. Okay, then you want the modulus, all you need to do is to put a modulus sign, then f bracket x. So you see, I don't have to retype everything, just type fx can already. Bracket. Before was black, after is red. Before is black, after is red. Can see, just reflect up. Yeah, 0 to 2 pi, so maybe it's only until here. Yeah, the M shape. If you want, you can also curly brace and then 0, comma, no, not comma, sorry, less than equal, x less than equal to 2 pi. Same thing for the modulus. I'll just retype the whole thing. 0 less than equal, x less than equal to 2 pi. So before was black, after is red, M shape. Okay. Good. Move on. No questions?
No.
No? Okay, good. 25 is done. Let's move on. Oh, finally done. Next one. 17.2. Let's see. 17.2. Okay. So most of them are well done. Just be careful when you do product rule with the d by dx notation. Make sure you got the extra pair of brackets around here, because it may, without the pair of brackets, it may be easily misread as an invisible pair of square brackets here. Right? Then you'll be using product rule again, which is not so accurate. Yeah. If not, you just don't. You just immediately evaluate differentiate x plus 1, which is just 1, or differentiate e power 2x, which is 2e 2x, then times x plus 1. Then that won't have any confusion. You write down the final answer straight away. Yeah, but for starters, I think you need not need. Correct. Yes, you have to draw the extra pair of brackets around the d by dx. Okay, no questions? Yes, no.
No.
Good. Moving on. Next, question 6 is fine. This one important, must have an extra pair of brackets. This one you never put, it's immediately wrong. You see, without the brackets, it means you differentiate this, you get some answer times e power 2x plus 1, totally separate. The brackets are necessary. You never put, it's wrong. Okay, just be careful of that. 2 or more terms, you must put brackets. Just write this down. 2 or more terms, pair of brackets around the expression. Here, 1 is a term, e power 2x another term, so 2 terms. 2 or more, put a pair of brackets around it. Okay, over here you also put a pair of brackets, 2 or more. Okay, moving on. Over here, okay, actually this one don't need a pair of brackets. Cosine x is understood. It's unlikely that there will be a cosine of like cosine of x times derivative. Okay, maybe it could be, but just to be safe, I guess maybe just put a pair of brackets, okay, to separate your expressions. Okay. Very important. Brackets are very important. Please learn. Okay. Moving on. All correct. Here not correct. Dy by dx. When you have e power something, you differentiate, you get back the same thing. That's your first step. Get back the same thing. But over here, you didn't copy exactly. You see, you put down 2x, you never put -1. You get a mistake?
Yeah.
Also, this is not notation-wise. This English. This is not the gradient of the tangent. This is the gradient function. Gradient is a number. Gradient function is a expression in terms of x. Okay, just be careful of that. Because it has x. Gradient is a number already. You replace the x with a number. This one is still function. Okay, so let me just do this question for you and yeah, nothing else. Yeah, just do it. Okay, move on. No, not move on. I mean, do it. Question 13, part 2. Or part 1. Part 1 wrong. Need to start from part 1. So we have a y equals to e to the power of 2x minus 1. They tell you the domain 0 less than equal x less than equal to 3. So anything outside of the domain, don't care. Less than 0, don't care. More than 3, don't care. Not relevant to the question. Yeah. Find the equation of the tangent and of the normal to the curve at the point A where x equal to 2. So A is 2, question mark. Your job to find out what's question mark. So let's just do that first. Sub x equal to 2, what do we get? We get y equals to e to the power of 2 times 2 minus 1. 2 times 2 is 4, 4 minus 1 is 3, so e cubed. So A is actually 2, e cubed. E cubed, if you type in a calculator, is approximately 20.0855. I'm gonna use the exact value. Don't use the approximation. Let's try and find the, what's our objective again? Maybe we should write this down. Equation of tangent. This is not a rate of change question. Equation of tangent and equation of no rate of change. Normal, at the point A. 3, e cubed. Okay, so there's a x, there's a y. So how do you find the gradient of how do you find the equation of a tangent? It will be, what is the equation? It's y equals mx plus c. There are 2 quantities to find, the m gradient and the c, y-intercept. Don't need to find y-intercept. Just find the gradient. That's the focus. Then use point slope formula, right? So what is the gradient? It's just dy by dx, right? Which is exactly what you wrote. But you want to substitute x with 3, right? Okay, we can do that later. Let's just find dy by dx first, later than sub 3. So e power anything, answer is, when you differentiate it, the answer is copy and paste the exact same expression. So you see 2x minus 1, just copy exactly. Clear? First step. Then multiply by chain rule. Take the derivative of 2x minus 1. Continue copying down everything. Differentiate 2x minus 1, what do you get? 2. Differentiate minus 1, what do you get? Minus 0. Don't need to write minus 0. It's just 2. So as a result, we get 2 times e power 2x minus 1. Is that okay? This is the gradient function. Can? Good. So now we want to find the gradient, which is the m. Let's just call it m. dy by dx, but you sub in x with 3. So you find the gradient already. You just substitute everywhere that you see an x with a 3. So what do we get? 2 times e power 2 times bracket 3 minus 1. So we must remember that e power anything, the anything must be have a higher, what do you call it? Operator precedence. Okay, better don't say that. I mean higher priority. Let me just write down what I just said. Operator precedence. If you learn programming, you'll learn about this. Basically, order of operations, which is higher priority. Power here has higher priority. So you must calculate first. Higher VIP, I'll just call it VIP. VIP, high priority. Okay, so we must calculate first. So 2 times 3 minus 1 is what? 6 minus 1, 5. So 2 times e power 5. I am trying to keep it in exact terms. If you type in a calculator, 2 times e to the power of 5, you'll get approximately 296.826. I don't want to use the non-exact value. Let's just use the exact. Okay, that's good. We got the gradient. So how? What's next? How to find equation of tangent?
So
What's the formula we know? What do we have? We have the gradient.
x dy over dx.
Sorry?
Wait, can we just, yeah, we have dy dx. So we have the gradient.
Yep,
Then
2 times.
Y equals to mx plus c.
That's the Sec 1 version. Amax, you learn a new version, right? What is it?
y2 minus y1 equals to m bracket open x2 minus x1.
Here I need to correct you a bit. Only one of the index. Drop the 2.
Oh, okay.
Drop the 2, okay? Carry on. So leave the y as y. Well, what's x1, what's y1? There's a x1 and y1. Should put a subscript like this. Can you see? The point given to you?
Yep.
So
minus.
This is called point slope formula. Point slope. Gradient and slope mean the same thing. Point slope formula. Why is it called point slope formula? Because you literally need a point and you need a slope.
Oh.
The x and y leave alone. Yeah, that's why it's called a point slope formula. Yes. So what's y1? E power 3 equals, what's m? Gradient.
Two e power 5.
Yes, the 296.826. But I use exact value. That's why it looks a bit funny. Bracket?
Bracket x minus 2.
X1. Where's x1? Where I get my y1
Wait, I
from?
mean 3. 3.
3, yeah, okay. Don't scare me, why got 2? 3, don't be confused. Hey, no, I was wrong. Let me see. Point A is x equal to 2. I made a mistake. I'm so sorry. This should be a 2. You're right. Yes, it's a 2. I made a mistake. Let me change that. It should be a 2. Sorry, it's a 2, not a 3. Okay, carry on. And actually, you're done. This is the answer already. Just have to rewrite it nicely. So let's bring the e cube over, plus 2e power 5 times x minus 2 times 2 is 4e power 5. So these are 2 separate terms. So please don't go and combine them, okay? This one has a times x, this one don't have. Don't go and combine them. Like plus 2 minus 4, then become minus 2e power 5. No such thing. If you want to rewrite it as mx plus c format, it will be like this. That's my m, that's my c. Okay, let me show you another way. If you cannot remember your point slope formula, you can go back to your Sec 3 method. Sec 3, usually people learn this in Sec 3, where we know the equation is y equal mx plus c, and we found the gradient 2e power 5 already. We can just sub in, so 2e power 5 x plus c. Now just need to solve for c, right? What do you do? Point slope. You already use up the slope, 2e power 5, right? So what else do you think you need? You got two options, point or slope. Slope used already. What else is left?
Points sub x equal to 2, y equal to e power 3.
Yes, exactly. Sub in the point. Okay. You must remember it's either the point or the slope. Those are the only two useful things. Usually. Then sub in the x with 2 for c. Solving for c, you realize it's the same. 2 times 2 is 4. So e cubed minus 4e power 5. So you can sub back in y equals to 2e power 5x plus c. But what's c? We just found it. E cubed minus 4e power 5. Answer. Same as the previous one. Okay? Can? Very good. Okay, let me try and write mine 5 more neatly. It looks like a 3. A bit confusing. Okay. So it's a 5. This is a 2. Oh, my handwriting very bad. Okay, Ken. Good. Part 1 is not done. We still need to find equation of the normal. So over here, just a quick one, equation of normal. Key idea is the gradient becomes -1 reciprocal. So you just need to take whatever you found from the previous one, but this time you must put a -1 over. So how would it be like? It would be -1 divided by 2e power 5. And that's the answer. I leave you to simplify it on your own. Make y the subject. Okay? Can? Just change the gradient from 2e power 5 to -1 over. Can I? Any questions?
No.
No? Okay, good. Next one, part 2. Given that the tangent and the normal cross the x-axis at the points B and C, find the area of the triangle ABC. It's the same question again. So here, maybe we can just draw a quick sketch of the curve, of the original curve, 2e power 2x minus 1. So hopefully you remember how e power x looks like this. Right? Yes?
Yeah.
Then if you change it to 2x, it just becomes steeper. So no difference. But what happens if you have a -1 here?
Go down -1.
Wrong. Don't go down. You go
up
left.
-1. Oh,
You
go
go,
left.
you go left -1. And in fact, actually, it's not 1. It's sort of a half. Okay. What you're doing here is this is actually 2 bracket x minus half, right? So you can think of it like this. You start with e power x. You transform into e power 2 times of x. Then you transform into e power, substitute the x with x minus half. Okay, so at first, maybe if I make it a bit more dramatic, it'll be like this. Oh, this is e power x. Then afterwards, you have e power 2x. Okay, make it steeper. Actually, technically, what happens is that it goes above and it goes below. Can you see? It's below, it's above. Below, above. Right? Then after that, when you have a x replaced with x minus half, you shift the graph half a unit towards the right. Okay, so I just copy and paste. Oh, I'm running out of space. Wait a minute. Let me just do this at the new page. Wait, no, paste. Good. Okay. This guy, where was my original function? There it is. So it goes down and it goes up. Then after that, you have a minus half here. What happens is that you shift half a unit towards the minus. What do you think is the direction again? Left or right?
It is left.
That's what you think, but this, contrary to what students commonly think, it actually goes towards the right. Good intuition. Negative number line, left side is negative, right side is positive. But over here, you have to be careful. When it's a minus half to the x, the graph will shift towards the right. Think of it like this. You're sort of like you're playing a game, then there's you play Pokemon or anything.
Yeah.
Yeah, somebody put a tail whip on you, your defense drop. So what do you need to
okay.
do to fight back? You must get stronger. So that's why over here, or maybe somebody growl and then your attack drop. Then you have to choose a stronger move to compensate. So that's why over here, you also have to be stronger. You have to shift half a unit towards the right to counteract the minus. Okay? Somebody growl you, you must choose a stronger move to deal the same damage. By same damage, I mean the same y coordinates. But this is already going a bit beyond Amax. It's actually H2 math already. So this becomes a new graph. Y equals e power 2 times of x minus half, which is actually e to the power of 2x minus 1. Okay, let me just highlight it in green. Okay, and this one is purple. That one is yellow. Okay. Good. All right, moving on. So now this is just the original curve, and what's really important is the tangent. So to draw a lazy curve, this is how it would look. Something like this. That's all. It passed through. This is y equals e power 2x minus 1. That's it. Don't need to stress too much. This is 0, comma, let's see. Sub in x with 0, 2 times 0, 0. 0 minus 1 is -1, e power -1. 1 over e. Good. Next, y-axis, x-axis. We need the tangent and the whatever normal line. It's at point A, 2 comma e cubed, so it's somewhere here. There'll be a tangent line, so maybe it's something that looks like this. L tangent. Then there's a normal line, so probably look something like this. Normal, 90 degrees. L normal. There is my point A, which is 2 comma e power 3. What did they want again? Let's read the question. Point tangent and the normal cross x-axis at points B and C respectively. So tangent cross x-axis at B. Tangent, point B. Normal, point C at the x-axis. Right? Okay, let me just bring this down. So where's my point B and C? Here and here, right? Yes?
Yeah.
Tangent is at point B, so this is point B, there's point C. Then find the area of this triangle. What angle is it over here?
What angle? 90.
90, because it's a straight line, right? Tangent is a straight line. So of course it's a 90 degree, which means that, how do you find area of triangle? When you got 90 degree. Half times. Do you really need sign? Only it's just, what's the area of triangle formula? The primary school one.
Primary school. Wait, what do you need?
Area of a triangle formula to help recite how many? Half times
base times height.
Very good. So where's my base? Where's my height?
It is ACAB.
AC height AB. Okay, do you realize this is exactly the same question?
Yeah.
Yeah, Okay, I'll just quickly go through it with you so that you can see how to get the exact value answer. Okay, so let's see. So equation of the tangent, we already have it over
Sub y
Yeah.
equals 0 into equation of tangent. Sub y equals 0 into equation of normal. Then you get point B, you get point C. Then after that, you can find length of a line, square root, bracket open, sub y coordinate in minus other y coordinate, and then bracket square plus bracket open x coordinate minus other x coordinate bracket close square. Then you find the length of the two lines you sub in, then you times half.
Exactly, yes. Yeah, you know the procedure already. Yeah. I'll leave it as an exercise for you. Okay, you try yourself. Let me mark your work. I will check it for you if you try. Okay? Yes, correct. Just use distance formula, find AC. Distance formula, find AB. Half times AB times AC. Okay. But you need to find coordinates of B and C first. Okay, next one. Population growth. Okay, so back to the exponential topic already. You've seen this type of question before. Just that we bring in differentiation. Okay, bring in differentiation. The rest is all the same. Sorry. Let's take a look. For part one is okay, just sub in t equals 0. Initial means our beginning means sub in t equals 0. Part two, this one you know y equals kx is the equation for x directly proportional to y. However, over here, what they ask you to do is to show that dp by dt is directly proportional to something. Here, dp by dt is replacing your y. Typically, the question would be in E-math, what they will say, the type of questions they'll ask is, y is directly proportional to x, right? Sometimes they make your life difficult, they'll have square root x, that kind of thing. Then it's y equals to k times square root x. But here, what they are doing is they are changing the y to dy by dx. Oh, sorry, not y and x, it's dp by dt. I must update the variable according to the question. Okay, adapt according to the question. Okay, so what they're asking for is this equation, something like this. But they're asking you, this guy, they never give you the square root x. They're asking you what is that square root x. Solve for question mark. Do you understand the question now? So how can you possibly get an equation like this in order to find dp by dt, involving dp by dt? Right? If you can get this equation, then you can find your question mark.
Yeah.
Very simple. You started with p. How do you find dp by dt? Just when you're lost and confused, you don't know what do. Just whack only. Differentiate. Right or not? Write the equation at the start, then differentiate. This is p in terms of t. Then just differentiate with respect to t. Make sense? That's all. That's all they need you to do. Okay, here I draw apple and durian for you. That's a durian, okay? If I say apple is directly proportional to durian, it means apple equals k times durian, where k is a constant. Okay, take note that over here, the m, just pretend it's like 20 or something. It's just a constant. It's just a constant. Okay, it's just a constant. So let's take a look. dp by dt means differentiate the p, which is 650,000 e power mt. Factor 650,000 can factor out. Then differentiate e power mt. E power anything, how to differentiate? Keep the same thing. Multiply by. Inside, differentiate. Why? Chain rule. D outside, D inside. Clear so far? Lost. Need me to repeat anything?
No.
No, okay, move on. Next, differentiate mt with respect to t. M is just a constant, so pretend that m is like 20. So differentiate 20t with respect to t. What do you get? 20. Then now if it's m times t, 20 is 20. M is m. 20t is 20. Mt is m. Does it make sense?
Okay.
Can, right? Okay, good. So that means you're left with M. So let's just do some shuffling. Multiplication, you can change the order any way you like. So how about 650,000 followed by M, then e power mt? Or how about yet another way to shuffle it? Why don't we put M at the front, 650,000 followed by e power mt? Can, right? From here to there.
Yeah.
Okay, good. But what's so special about rearranging it this way is that 650,000 e power mt, it looks very familiar. Where have I seen it before?
P.
Exactly, it is P. So it becomes M times P. To conclude, dP by dt equals to M times P. Analogy with apple equals to K times durian. Apple is directly proportional to durian. dP by dt equals to some constant times P, means the dP by dt is directly proportional to P. So to answer the question, show that the rate of increase is directly proportional to the proportional P. Yeah, that's it. We managed to show it. Oh, they actually didn't ask for the question mark. They already told you the answer is P. Sorry. No, this wasn't a question mark. This was already revealed to you as P. Yeah, at the beginning. Sorry, I said wrongly. I thought they were asking for this, but no, they already told you the answer is P. So they're just asking you to show dP by dt equals to K times P. Can understand the question?
Mm-hmm.
Okay, good. So what does this mean? It means that the rate of change of P, right? If you just analyze what this equation means, the rate of change of P is directly proportional to its own population size. So the bigger the population size, the faster it grows. Does it make sense?
Yeah.
P is bigger, dP by dt is bigger. Means the more people you have, the faster you grow. Means that you're just gonna grow faster and faster and faster, which is an exponential growth. Make sense? Like you double each time if it's 2 power. But here it's like 2.7, which is even faster. Like E is around 2.7, right? So e power x is really just multiple. Like for example, e power x, the x could be 1, 2, 3, 4, then it will be e or e times e or e times e times e or e times e times e times e, depending on the power. Yeah. So you just grow very fast. Anyways, the rest of your question is fine. Here I just try to show you an exact value answer. I thought that I could cancel off the e and the ln, but turns out that I can't really do it. Let me know if you can find a better way to simplify this up. But I'm just trying to do extra, give you an exact value for the answer, but it's not needed. Okay, for part VI 6, part 6. Estimate the value of t for which the rate of increase in population first exceeds 18,000. Do you understand what the question is asking?
No.
What's rate of increase in population? You see rate,
P over dt.
Exactly, dP by dt. Then exceeds 18,000?
More than.
More than. So it's an inequality. Then if you happen to get a quadratic equation, then you throw back to the first topic we learned, quadratic inequalities. But here in this case, dP by dt, you know, is MP, right? From part 2. So that means you can, I'm just leaving the M alone now. You already know what's the exact value of M, right? It's over here. Just a bunch of numbers. To save me some trouble, I'm not writing out everything. I just leave it as M. Okay. At the last step, then I replace it with the actual ln 199 minus ln 130 over 25. Okay, moving on. So anyways, we get M times P equals to is more than 18,000. Replace the P with the original expression. So here I divided by 650,000. It's a positive value, so the inequality doesn't change. I also divided by M. M is a constant. I assume it is positive. Let me just double check. Hold on. Yes, I can check that it's positive by typing this in the calculator. Right? Okay, so M is positive, which means that when I divided the M over here, dividing by a positive, the inequality symbol stays the same direction. Good. Then I simplify this fraction. I end up with 9,000 over 325 M. Okay, so e power mt is still strictly more than a fraction. How do I solve for mt now? What I do is I bring the e over. So it's essentially taking logarithm on both sides. Okay, let me just write it neatly. So e power mt more than 9,000 over 325m. What I'm doing is I'm taking ln on the left-hand side, ln on the right-hand side. ln and e cancel away. You're left with mt. ln and the ln of whatever is the expression there. I just realized that it's not 9,000, it's 9. Sorry, the 1,000 got cancelled off already. Sorry for the confusion. 9 over 325m. Right, then more than ln of that fraction. Very good. So now here, please take note that I don't need to change the direction of the inequality. The reason is because that, let me just write this down. ln of x is a monotonic increasing function. Monotonically. What's monotonic? Means that if you draw the graph of ln x, as x increases, what happens to the graph? It's always
Going up.
going up. Okay. Yeah. Then does it ever go down before it goes up again?
No.
Like some cubic curves, you see? No, right? Or like cosine curve or sine curve. No, it always goes up. So that's the meaning of monotonic. It never goes down. Okay? If that is the case, let's take a look at let's examine two types of functions. Let's say that you have this is, I don't know, let's say this is y equals to sine x, the first half. Over here is pi over 2. Let's say that here is 30 degrees. Let's say that here is 45 degrees. You get a corresponding y value, sine 30, sine 45. I'll just use degrees. I know the exact value already, but I want you to pay attention to the position of sine 30 and sine 45. Do you notice that sine 30 is below sine 45?
Mm-hmm.
Yes, from the graph, yes. So that must mean that sine 30 degrees is less than sine 45. But you started with 30 degrees less than 45 degrees. So when you apply sine here, the inequality direction doesn't change. Do you see that?
Mm-hmm.
Apply sine, inequality direction doesn't change. That's only because this part of the curve is monotonically increasing, this part of the curve. However, if now I go to a second part of the sine curve, which is now decreasing. So let's say that this is, okay, I better don't use radians. I'll just stick to degrees. Let's say that this is a 100 degrees. Let's say that over here is 180. So this is something smaller. So let's say 170 degrees. You go up. Then there's a corresponding 100 degrees, comma, sine 100 degrees. Versus 170 degrees, comma, sine 170 degrees. Can you see that? Sine 170 degrees is below sine 100?
Yeah.
So that must mean that sine 100 degrees is bigger than sine 170 degrees. Agree so far? 100 is above, 100 is bigger. But you started with 100 degrees less than 170 degrees. Can you see that? This time, when you apply sine on both sides, what happens to the inequality symbol? Compare with the previous one. What happened? Less than becomes more than. This one, change. Stays. Okay? So when you apply sine to both sides of an inequality, can you always keep it in the same direction?
No.
Not always. So what's the rule? When do you need to change it? When does this happen? Or why? Why? Hint. Red color part.
Or cause either ascending.
Yeah, that's it. Yes, ascending, descending, increasing, decreasing. From the graph, it's very obvious, right? When it's increasing, your y value will inequality must remain. For when it's decreasing, then the inequality direction must change. Okay, that's a key rule you need to remember. So when we teach you like a multiply by -1, you need to flip the direction. It's actually and you can actually think of it like this. There is a y equal -x function. Okay, then we have like, let's say this is 1, this is 10. What's the corresponding y coordinate if you have x equal to 1? Sub x equal to 1, -1 over here. Sub x equal to 10, you get negative
-10.
10, yes. So look, 1 is less than 10. Multiply by -1 on both sides, -1, -10. What happens to your direction of inequality? Flip, right? Is it convincing now with the graph? -1 is on top, -10 is below. And what's the reason? Now that the new thing you learn. Is it just blindly memorizing multiply -1, then you flip direction? No, what's the more general rule? You are applying a -x function on both sides, which is in this case, decreasing. Right, descending, like what you said. Okay, that's a general rule. Increasing function applied to both sides of our inequality, direction of inequality stays the same. Decreasing function instead applied to both sides of inequality, direction will change. Decreasing, change direction. Increasing, stays the same. That's the general rule. Multiply -1, you have to flip. That's just one special case of a decreasing function. Y equal -x. Clear?
Yeah.
Okay, so over here, what we are doing is we're applying ln, which is an increasing function. Increasing function, do you need to change? Or stay the same?
Stay the same.
Stay the same. Okay, very good. Now I have convinced you that this stays the same. Good. Next, you want to solve for t, bring the m over, divide by m. M is a positive number, so the direction will stay the same. Because y equal positive x is an increasing function, and you can also think of it that way. Then substituting m equal to this guy, you get the final answer, 28.544, which is around 28.5 years. Okay? Very good. Next. Radioactivity. Okay, I think it was fine, right? Yeah, for part 4, calculate the rate of decrease. So what does it mean? You're trying to find out?
T M, I mean,
yeah. Correct. Tm by?
Over dt.
Exactly, that's it. In terms of t, at time t hours means you substitute t with t, but that's not very meaningful, so just leave it in terms of t. You got the formula for m already, right? And the k. So yeah, you can just sub in the k, leave the t alone, then you differentiate m with respect to t. I'll leave you to do it on your own. Okay. Sub in the t with whatever you found. Use that k value. Moving on. Next, 26, common mistake. Okay, this one nothing much. This one just journal writing. To reflect on the difference between power. Okay, I write this down. Difference between a power rule, which is bring down the old power times the same base -1 to get the new power, versus differentiating a constant raised to a variable. Okay, and in this case, the constant is not n, it's e. you get e power x. Question, extra bonus question. What happens if I want you to differentiate 3 to the power of x? Then how? What is the answer?
3 to the power of x. You bring down the x.
Bring down the x and then minus 1? Or
No.
can you apply the e power x rule, then just copy 3 power x and then differentiate x to get 1? So 3 power x. No, cannot, right? We only applies when the base is a e. Base is a e. Here is a base 3. So the base is different. If only we could change the base. If only there was a formula that could help us to change the base.
Yeah, if only.
A change of base formula. No impression at all.
A change of ln 3 ln x.
Wait.
Wait, I mean
It's not a
L. Wait, as in. Wait, what?
Wait, no. Sorry. Not correct. Change of base formula only applies when you're dealing with logarithms. Like change of base, sorry. Not correct. Log A base B equals to log A on top, log B below. Then you put a common base. Yeah, that's only for logarithms. Sorry, I misled you. This one, well, we don't exactly have a very precise change of base statement, but you can change its base. You can rewrite it as e to the power of ln of 3 power x. Can you see? E and ln cancel away. And you're left with 3 power x. Right? So that means that this is just e to the ln of 3, but it's a power. You can use logarithm property to bring it in front. So x times ln 3. Ln 3 is just a number, right? So maybe we can rewrite it as some coefficient times x. Can you differentiate this? E power something x. Can. Keep the same thing times x multiplied by inside function differentiate, which is just ln 3, right? Not to be confused with differentiating ln, you get 1 over. Here, ln 3 is just a number. It's a coefficient of x. Differentiate something x is just something. Good. So simplifying, e and ln cancels off again. You're left with the x times ln 3. So in other words, the derivative of 3 to the power of x. Sorry, did I do something wrongly? Yes, I did wrongly. I cannot just cancel off. No such thing. The ln must be applied to the entire thing. So let me just correct myself first. This part need to do a bit more modification. This is multiplication. If I just rewrite it as the x in front, x times ln 3, I can bring the x back on top to the power of 3, right? Because of logarithm property. So this is what I'll get. But now I finally have e to the ln of 3 power x. What happens to your e and ln? Cancel off, right?
Yeah.
Don't forget the times ln 3. After they cancel off, what are you left with? 3 power x again times ln 3. There you go, that's the answer. Differentiating 3 power x, you keep the same thing. However, because this is no longer base e, you need an extra times ln of that constant base 3. Let's generalize this. So d by dx, you can go and work it out on your own. It will just be a power x times ln of a. This is not in your syllables, it is H2 max. When we change the base from an e to a different constant, let's say a in general, you have to have extra ln a. So if I just use this formula, I A equals to constant E, the 2.71828. What I end up with is d by dx, e power x. A replaced with E, so we get e power x times ln of A, which is E. What's ln of E again?
L1.
It's 1. So this means e power x times 1, which gives you back to e power x. Okay. E power x is just a special case of the general formula over here. But this is not in your syllables. This is H2 max. Okay, A level. Just let you know, but it's within your reach. Extra. Don't need. Okay, here the question is just warning you. Take note of this main difference. We have a base here that's a variable. We have a power that's a constant. But over here, the base is the constant and the power is a variable. Swap around. In particular, the base is a specific constant E. Not in your syllables for the general version of a constant A. Don't need. Just E will do. The simple case. It's an extra complication. Can ignore it for now. Okay, these are the two differences you must know first. Okay, you must be very, very clear because the next topic we're going to go on. Okay, for today, I haven't introduced integration. So I will need you to go and do a bit more practice questions on the differentiation. Okay. Then tomorrow, no, not tomorrow, next week, we will go through some of those questions, assuming that you've already done that. Then I will also start the topic of integration. You must be very familiar with all your rules of differentiation already, because we're going to start working backwards. Integration. Yeah, new topic. Okay.
Okay.
Can I also send you some videos you can go and watch if you want on integration ahead of time. Yeah, that's all for today.
Okay. Thanks.
Thank you. All right. Bye-bye.
Bye-bye.
Bye-bye.